Hi guys! So today I'm going to be filming my first YouTube video. Before I start, I'll give a little introduction. My name is Eileen. I go to Texas A&M University. I'm a public health major on a pre-dental track. And I enjoy trying new foods. So I also want to give a notice that I do have a speech impediment. So if that ever becomes an issue, I apologize. But let's go ahead and get started. Today we're going to be discussing chirality and identifying chiral centers. So chiral molecules are non-superimposable, meaning they are not mirror images or they do not have mirror images. So let's look at this picture. When we look at our hands, and if you try to put your hands on top of each other, you can never make them mirror images, making them non-superimposable, or in other words, chiral. But when we look at that flask at the bottom, if you put a flask in front of another flask, they are mirror images, which are superimposable, meaning they are achiral. Chiral molecules have no plane of symmetry. When we look at this methyl cyclohexane, we see a plane of symmetry, so we can conclude that it's not chiral, it is in fact achiral. And lastly, a molecule is usually chiral if it has a chiral center. So now moving on to how to identify chiral centers, we need to understand that chiral centers are sp3 hybridized carbons with 4 different groups attached. So let's go ahead and work these problems out. The way that I recommend approaching them for the first time is looking at each carbon in the molecule. I know that seems like a lot, but I promise it will get easier and it will get to the point where you won't even have to do that. You'll just be able to identify the centers. All right, let's go ahead and look at these carbons. We also need to understand that these methyl carbons have invisible hydrogens, and there's 3 of them. It is sp3, but because it has 3 carbons attached to it, we know they're not chiral because remember, we need 4 different groups attached. Moving on to this carbon, we have 2 methyl groups, and there's also plane of symmetry, so we know it's not chiral. Now, what about these carbons? They're not chiral, and we know this because for one, they're sp2, and remember, we need sp3. So immediately, no. All right, let's move on to this carbon. Same thing. This is an sp2 carbon, not chiral. Now, as when we first started, these are methyl groups. We know they're not chiral. We have 3 hydrogens attached to them, and we need 4 different things. No. What about this carbon? This carbon has 2 hydrogens. It is sp3, but we need 4 different things, not chiral. What about this one? We have a methyl group, an ethyl group. We have all of this attached to it, and we also have an invisible hydrogen. That's 4 different things, and it is also sp3. This is a chiral center. Let's move on to this one. Immediately, oh, my apologies. We know that these carbons are not chiral centers. They have 3 hydrogens attached, and we need 4 different things. What about this carbon? 2 invisible hydrogens, not chiral. What about this one? We have 2 methyl groups, not chiral. So this molecule is known as achiral, meaning no chiral centers, not a chiral molecule. What about this one? Remember methyl groups, not chiral. And we can also understand that these carbons are sp2. I'm sorry, not sp2. They have two hydrogens. I apologize. They have two hydrogens. So we know it's not chiral because we need 4 different things. What about this carbon? 2 methyl groups, not chiral. What about this one? So some may think that this carbon is achiral, but really it is chiral. Let me explain. So when we look at this, we have this group attached to it. We also have this attached to it. But this is not the same as this because this side has this group. So it's technically different. And don't forget that invisible hydrogen, making that carbon chiral. What about this one? We have this attached to it, this attached to it, the hydroxyl group, and the invisible hydrogen. It's sp3. That's 4 different things. Chiral. What about this one? We have obviously the hydrogen. We have the methyl group. And now let's look at both sides because it might look like it's achiral, but it really is chiral because this is not the same as this. We have this attached, making it completely different. So making that carbon chiral. Let's move on to this one. I know this one seems scary, but we can immediately eliminate this carbon, this carbon, this carbon, and this carbon. Why? They're not sp3. Okay. Remember that usually carbons that look like this have 2 hydrogens unless specified that they don't, not chiral. Remember that methyl groups, not chiral. So let's take a look at this carbon. We have a methyl group, we have this, we have this, and we have the invisible hydrogen, making it chiral. What about this one? We have the methyl group, we have all of this, they're not the same, plus, sorry, I lost track, plus this, completely different, making it chiral. Lastly, let's look at this one. We have this, this hydrogen, and this down here, making it chiral. So remember that a chiral center is sp3 and has 4 different things attached to it. So try this one on your own. I know it seems scary, but it's not. Look at each carbon and I will give you a hint. We immediately know that this carbon and this carbon are not chiral because those are sp2 and we need sp3. So take some time and then we'll go over it. All right, so I hope we all got the same answer, but I'm going to highlight the chiral centers. All right, I hope we all got the same thing, but let's go over them. So let's start with this carbon. We have the methyl group attached. We have all of this. We have this. And we have a hydrogen. It's sp3, 4 different things, chiral. All right, let's move on to this one. We have the OH. We have all of this. We have all of this, and we have a hydrogen. 4 different things, sp3, chiral. Let's move on to this one. We have that hydrogen. We have the CH3 group. We have this, and we have this attached. 4 different things, sp3, chiral. Let's look at this one. We have this group, this ethyl. We have all of this attached. We have all of this attached. And we have that hydrogen, sp3, 4 different things, chiral. Let's look at this one. We have the methyl. We have this attached, this, and that hydrogen, chiral. Same thing with this one, that hydrogen. All of this, which is different from this, chiral. This one, we have the methyl, we have that hydrogen. Now, I know it may be confusing because there's 2 OHs near each other, but remember, chiral molecules do not have a plane of symmetry. So if we if we draw a line here and we look at both sides, they're not the same at all. Not even close. So don't get confused. Make sure you analyze the complete surroundings to understand that this right here is chiral. Let's look at this one. We have the OH, hydrogen. We have this attached, this attached. We understand it's chiral. This one, we have the OH, the methyl. We have this, chiral. Lastly, we have a methyl group. We have this attached, and that invisible hydrogen, making it chiral. So I hope I made this lesson easy. I try to break it down as easy as possible, the same way that I learned it, because I understand sometimes it's hard to understand these topics. Let me know if you guys have any questions. And the main rule or main advice I can give as an OChem student is repetition is key. You have to repeat this, you have to practice, and it will come easy. Thank you so much for watching. If you like it, please give it a thumbs up and feel free to subscribe. I will be uploading new videos whenever I have time. And if any questions, let me know. Thank you.